So we just saw Frank Jackson's argument against physicalism, where he says, look, imagine there's the scientist who knows every single physical fact about color vision, but she's learned all these facts while being locked in a black and white room her entire life. So when she leaves that black and white room, she learns a new fact when she looks at, say, a ripe red tomato. In particular, she learns this new fact, what it's like to see red. But since she already knew all the physical facts about the universe, this new fact that she learns must be some non-physical fact. So physicalism is false because there are some facts about the world which are facts about non-physical things, these qualia, these experiences of what it's like to see colors or hear sounds or taste flavors, etc. So here's another sort of argument that also argues that physicalism is incorrect. This is due to the philosopher Thomas Nagel, and Jackson talks about it in his article. So this is the what is it like to be argument. So think about a bat. So it turns out that bats get around by using echolocation. They emit tiny little chirps of sound, and then they listen to how those sound waves bounce off objects like little moths that they might be trying to eat, or in particular the walls of caves or rooms they might be flying around in. And those sound waves bouncing back allow them to perceive where that moth is located, how fast it's going, in what direction, where the walls are, so they can avoid hitting the walls. So they use this echolocation to perceive their universe, and you might wonder, I wonder what it would be like to be a bat like that. In fact, I in particular, I wonder what it would be like to perceive my environment using echolocation or sonar instead of, well, I usually use sight in my case. I wonder what it would be like to use echolocation. And what Nagel argues is, well, you're just not going to be able to imagine what it's like to be a bat. You're not going to be able to know, in particular, what it is like to be a bat. And here's his diagnosis. He says, look, knowledge of what it's like to be a bat is subjective. And by that he means something very specific. He means it depends on having a particular point of view. To know what it's like to be a bat, you need to take the perspective of a bat. You need to kind of be in the point of view of that particular bat. So this knowledge of what it's like to be something is inherently subjective in this way. It depends on a particular point of view. But then Nagel notice knowledge about physical facts is not dependent on any particular point of view in this way. Physical knowledge is objective. A physical fact, like, for example, the height of the Empire State Building, that is a fact that you can get knowledge of from many, many different points of view. You don't have to look at it from any particular angle or position. You don't even have to look at it at all. You can use other sorts of information to figure out how high the Empire State Building is. So knowledge of physical facts like the height of the Empire State Building, or even knowledge of physical facts like how a bat's brain processes the incoming signals, you can gain that knowledge without having to take a particular point of view. Lots of different individual scientists, all from their own different points of view, seeing out of their own eyes and hearing out of their own ears, can examine how the electrical signals go in a bat's brain when it is navigating using echolocation. Those are all physical facts that are objectively available to you no matter what point of view you take. So physical facts are all objective, but knowledge about what it's like to be a bat, that seems to be subjective. Well, so then that knowledge of what it's like to be a bat must not be a knowledge of physical facts because it has this property, this subjectiveness that physical facts just don't have. So, knowledge of what it's like to be a bat must not be knowledge of physical facts. So, Nagel can conclude, yeah, there's something wrong with physicalism here. There seems to be certain things, like knowledge of what it's like to be a bat, that you just cannot capture in terms of physical facts. So, one more argument I want to hit you up with, and this is one that was not in the reading, but I think it's one that really, frankly, I find the most compelling. And this is the explanatory gap argument. This is due primarily to the philosopher Joseph Levine. And so what he points out is, look, when you try to explain certain things, when you try to explain, in particular, the nature of qualia, what it's like to experience colors or what have you, and you try and explain that in terms of physical phenomena about, say, the electrical chemical signals our neurons are sending, there's just a gap. It leaves something unexplained in there. So let me give you an example of an explanation that doesn't have a gap. So, as you can see in this photo here, when you freeze water, water expands and it becomes solid. This is, you probably knew that already. It's a well-attested phenomenon. You can see, those jars were full of water, but then when it froze, that water expanded, so it came all the way out the top of those glasses. And now you might wonder, I wonder what explains that. In particular, because most liquids, when you freeze them, they actually become more dense. They shrink in volume, and yet for some reason, water, when you freeze it, it becomes larger in volume. So you might ask, well, what's the explanation for that? And well, it turns out you can give an explanation of that. You say, so water is actually just a big group of H2O molecules, and when they've got enough energy, they're all able to just kind of like crowd together and jumble amongst one another, like on the image at the left there. But it turns out that some of those hydrogen atoms, they're able to bond with the oxygen atoms, but when it's warm enough, those bonds are pretty weak, so they don't really hold it together very firmly, and so they're all able to party and like really jiggle up close to one another. But when you take energy out of the system, when you freeze the water, which just is a big group of H2O atoms, then those hydrogen bonds are all of a sudden able to really take hold, and they turn out locking in to these hexagonal structures, like the one on the right here, in ice. And you can see that when the molecules of H2O are arranged like that, they're going to take up a whole lot more room than when they're arranged the way they are over on the left here. And it seems like, oh, yeah, that makes sense. That's a pretty darn good explanation. I can see how, if you took the molecules like that and that they had the special property of spreading out into these hexagonal structures when they froze, I can see how if you do that with a bunch of them, it's going to make the water expand when you freeze it in a glass bottle. There's no gap in my understanding there. I understand how that works. But if you ask then, instead, you want to explain, well, why is it that you have one kind of qualitative experience when you look at the photo on the left here, but you have another qualitative experience when you look at the photo on the right here? And I try to explain that by saying, oh, well, the one in the left over here, one kind of cone cell is firing, and that causes certain electrical signals to go back in your brain. But over on the right here, that causes another kind of cone cell to fire, and that causes other electrical signals to propagate in your brain. I might say, okay, yeah, sure, I get that, and maybe that explains why I have a different experience, but why aren't they just flipped? Why do I see the peppers on the left here the way I see them, as opposed to seeing them the way I see them on the right over here? What is it about the one cone cells that gives me a red qualia as opposed to a green qualia? I don't know. There seems to be a bit of an explanatory gap there. Just telling you all the details about the chemistry and the electrical physics of what's going on in your retina and your brain doesn't seem to really explain why the peppers on the left look red and the peppers on the right look green. I can understand why the one looks different than the other because there's a different electrical activity happening in my brain, but I don't understand why the one sort of electrical activity gives rise to these red qualia and the other one gives rise to the green qualia as opposed to the other way around. So I'm still lacking some explanation. And that's where you might think, right, that's why folks like Jackson think, look, you can study all you want what's going on physically in your brain, but it's going to leave something out. It's not going to give you knowledge about just what it is like to have the sorts of experiences that you have when that stuff goes on in your brain. And so that makes it seem as though physicalism must be false. There must be more to your mind than just physical facts about what's going on in your brain. There must be these non-physical facts about these qualia, what it's like to have these conscious experiences of tastes and smells and sights and feels. When I come back, we'll take a look at some of the ways in which philosophers, particularly Patricia Churchland, have pushed back against this idea and defended physicalism.